overall height. Usually, ang moment of inertia is BH cubed over 12. Okay, so that would be the formula. So instead of using kining 100% ani, so pag compute mo, BH cubed over 12, then kung column siya, i-multiply pa natin siya by 0.7. Okay? Usually ang column natin circular man, no? Kung circular, then na-formula ang circular, moment of inertia, then you have to multiply again by 0.7. But in the usual cases, no, in most cases, ang atong columns, rectangular talaga. Rectangular. Kung na may circular, ano na siya, architectural lang. Architectural. Usually, rectangle siya, o niya, gibutangan lang siya, kanong circle nga covering. Para parang siyang circular. But in most cases, we're using rectangular. So, the common formula is BH cubed over 12. While for walls, this is referring to structural walls or shear walls. So pag minomodel natin ang atong wall na uncrack, ito say at service loads, no? Yung say uncrack service ang yang load, no? 0.7 lang. So same with your column, 0.7. But if you model your walls to have cracks, no? Kung gusto mo yung model nga na siya cracks mo yung tabo, then 0.35 na lang of the gross area, no? Say of the moment of inertia. Same gapon, walls are rectangular gapon, so same formula. While for beams, no, 0.35 multiplied by its moment of inertia. Same gapon, BH cube over 12 times. Attention na itong 0.35. So again, if you compare the two between beams and columns, no, your beams is weaker than the columns. No? Okay, we assume that only 35% na lang ang stiffness sa atong beams compared to our columns nga 70%. So in practice, usually itong ginagamit. Instead of kayo nga one half ang beam and then one ang column. No? That's only for braced frames. But sometimes in actual structure, you do not know whether kung ano bang atong structure. Braced ba siya or unbraced. No? Okay? It depends on the behavior of the structure. So for general, usually in practice, no, yung ginagamit, no, pag beams 0.35 IG, for columns 0.7 IG. We have flat plates and flat slabs. So, na slab na directly supported by your column, then we will be using 25% of its gross moment of inertia. So, same gapon, limang slab rectangular. So, pag complete niyo money, multiply natin by 0.25 lang. So, very important ni siya, no? So, before ka mahuman sa imong model, make sure nga your column is 0.70 and your beams is 0.35. If you model your slabs, flat slab, then make sure you have to multiply that by 0.25. So, muna siya kasagaran ginagamit in practice. Okay? Then we have the modeling of frames. So, we can model the building in 3 dimensions. Okay, so we have an example, no? Paano ginagamit ito. No? So we have here, again, I'm using the same example. Katong gikuhaan nato ng column. Load moments and shears, no? In the beam along column line B. So kining beam ang atong kukuhaan, no? Sa kini siya nga beam. Kukuhanin nato siya og moments and shear, no? Kung kinato i-design kini nga beam, then we need to determine first the moments and shear, no? So kini lang, no? Atong consideration kini siya. Pilang yang moment diri, pilang moment diri, pilang moment diri. So actually, may determine natin nga moment is not a moment diri, no? Negative moment. We have okay, sama na itong target. Okay, so ayan. So last time. Okay, stop ko muna ako presentation. So our beams are 560 by 520. While ang atong floor, no, ang atong kinahanglan information is actually the weight of the floor, which is 4 kPa. No? So ito yung kailangan natin. Okay, so then we are using normal weight concrete nga 24 kN per cubic meter. No? So we are to determine the factor bending moments and shear forces in the beam along all of this. So take note, kini lang atong kina-consider. Okay, sige. So let's start with our solution. No? Okay. So, usually pag ganito, no, pag simple lang, no, we can expect that the dead loads and live loads is uniform all throughout the span. Uniform talaga ni siya, no. So the tributary width, no, is supported by the beams along line B. Okay? Equal to 1/2, no, of the transverse span in either side of the column. No? So 1/2. So dire 1/2 ani and 1/2 ani, no. So in other words, there is atong slide, no. Ang atong tributary area is let's say shape. Ang tributary area ni may nani, no. Let's say transparent na ta. Ito yung tributary area nimo. So this side here, 7,600 divided by 2. There, this is 6,700 divided by 2. So ang tibok ani nga length would be 7,600 divided by 2 plus 6,700 divided by 2. No? So that would be our, so 1/2 ani dire, then 1/2 dire. So let's compute, no? Ang atong first method is we have to calculate the tributary area, no? So calculate kita sa tributary area, no? Calculate so inside of tributary area, usually pag beam, tributary width lang, no? So tributary width. So again, 1/2 ani is 7,600 or 7.6 meter. Then this one is 6.7, no? So, okay, 1/2 ani. Then 1/2 ani. So 7,600 divided by 2 plus 6,700 divided by 2. Or that would be, let's say, tributary width. Let's say I'm using WT for my tributary width. So that would be, no? Ang first pa natin, 7,600 or 7.6 meters. 10 plus 6,700 will be 6.7 meters. No? Tapos, i-divide na natin sila tanan by 2. Oh, by 2, then that would be, okay, we have 7.15 meters. So we have already determined the tributary width. So the next step, we can now calculate the dead load. No? So calculate the dead loads. Okay. Dead loads. No? Okay, so first, consider natin ang atong weight of joist. No? Okay, so let's say na lang W, let's say joist. It's actually including na yung, so let's say weight of floor na lang, floor system. Okay, that's combination of your, the combination of your joist as well as your slab, no? That will be equivalent to the weight of the floor. So in combination now, joist, the weight of the joist as well as the slab, that would be the weight of floor, 4 kPa multiplied by the tributary width, no? 7.15, no? WP. That would give us the weight of the floor system in terms of kilonewton per meter. So per meter length, no? Usually pag beam, we express that one in per meter length. So kakonvert ko lang ni siya to kilonewton per meter, no? We have. Okay, so we have 28.6, no? Para sa atong weight of the floor system in kilonewton per meter. Next. So floor system na lang ni. Floor system, let's say floor system, no? It consists of joist and slab. Next, we have the beams, no? Beam ta. Okay. So pag beams, again, we're not given with the weight of the floor, but instead, we're given with the dimension, and we know that our beam is using a unit weight of 24 kilonewton per cubic meter. So to determine the weight of the beam, no, let's say W beam na lang. That would be the unit weight of concrete, 24 per cubic meter, no, multiplied by the dimension, which is B times H. No? The cross section B. And then, para parehas na rin, kilonewton per meter, no? We have to convert this to kilonewton per meter. No? So we have 6.988 kilonewton per meter. Okay. Aside from this, now, take note na siya is super, we have stations. Mga floor finish diha, kung na tiles, no, so we have to anticipate that one. So, ito, superimposed dead load. Then, ang iyang kunan, ang iyang pressure sa superimposed dead load is tawag na itong PDL, pressure and superimposed dead load, that is 0.5 kPa. 0.5, ay, nawala ako ng black. 0.5 kPa. Okay, so, tawag na natin din nga W SDL, no? Superimposed dead load. That would be equivalent to ang pressure para sa superimposed dead load in kilopascal times the tributary width, no? Okay? And then in kilonewton per meter para consistent sila tanan. Okay? So we have now the superimposed dead load in kilonewton per meter. So therefore, we can compute the total dead load, no? Total dead load, no? Usually ang dead load is WDL na lang. WDL. That would be equivalent to, okay, ang atong weight support system, and plus sa atong weight sa beam, and plus sa atong weight sa superimposed dead load, no? So that means, equivalent siya sa 28.6 plus 6.998, then plus 3.57. So, gawas na lang na direct. Okay, so we have the value. So, hibong ko lang yung kilonewton per meter. Okay, so for our dead load, ang atong total dead load is 39.1638 kilonewton per meter. Okay? So, next, compute kita sa atong live load. No? Kung na sa dead load, no? We're done with the dead load. Then, live load na ta. No? So, anong kinanglan natin magbutang og live load? Siyempre, para makompute natin og WU, no? Which is a requirement later on. Okay, so since it's a floor, no? Floor ni siya, no? And we have to apply, typical floor ni siya, we have to apply the live load reduction, no? So, reduce live load. Okay? Or apply live load reduction. Okay, so for floors, ang formula ginagamit natin is ang nasa atong slide, which is equivalent to L. We have L sub O, the nominal live load found in the code. So we'll be using the metric na formula, 4.57 divided by the square root of ALL times the tributary area. Okay. Now, according sa code, no, kung sa atong previous example, ang atong value sa atong KLL is 4. No? Ang atong KLL, we're using 4 sa atong KLL. No? This time, no, kay beam man siya, the value would be KLL is equals to 2. Okay? So, that's the value for beams. Ito ang value. Next, calculate natin ang by the way, this one, no? So, for office use, no, based sa atong previous example, pag office, this is equivalent to 2.9 kPa. Okay, this is found in the code. So, 2.9. So, this is office use. Okay, so this is coming from NSCP 2015. So, ikuha niya siya from the code, no? 2.9. Okay, next, we need to compute our A sub T. So, dapat wala siya unit, no? So, again, since ang atong tributary width, no? So, let's go back here. Ang atong tributary width is 7.15. And then, considering lang, ating consider, kinila ko sa span, no? Pareho sa mga dire. Okay, so, that would be, okay. Kininga length, which is 7.15 times this length nga 6.1. That would give us the tributary area. So, for sa beam, for one beam, inuna ning imo tributary area. So, width times the height. So, this one is 7.15 ang total ani times 6.1. Ito dere. A sub P is equivalent to ang atong tributary width, no? Which is equivalent to this one. So, di kita magamit ang WT because na siya unit. No? So, ang atong formula, wala unit. So, ang value na lang, which is pila to dire, 7.15. 7.15 times 6.1. So, aboy natin ng unit para unit ang formula natin tingin the answer. Okay, so compute na. Okay, we have Pascal and then let's make it in kilopascal. We have 2.144, no? But then there is consideration gapon sa atong code nga this one is supporting kung nagsusupport siya og 2 floors 0.4 and if supporting 1 floor 0.5. So okay, so let's call this one as L1 na lang, no? Okay, we have to compare that one with L2. Kung supporting 1 floor, di ba natin condition ang atong code nga 50%, no? We have 0.5 times L sub O. Okay? PPA, di ba? This is supporting 1 floor, no? Tapos, ibaningon ko siya nga whichever is smaller. Okay? Whichever is whichever is larger ani nila. Okay? So, this would be W, no? So, let's refer to the code, no? Kalimot ko sa atong code, no? I will be referring to the code. Say value ani. Okay, so, open muna ako ng NSCP. So, I forget the code exactly. Ano ba yun? Let's go to the code. NSCP. Okay, so, kasi sa amin, ano ba talaga to? Okay, yan. Okay, so this one. Okay, so we have here the code. Then, asa to ka provision. Adi, no? 40. Okay, this one. No? The reduced live load shall not be less than 50% of the unit live load for members receiving load from one level only. So shall not be less than 50%, no? Nor less than 40%. So in other words, no, whichever is larger. So dapat dili siya less than by 50%. No? So this one, since larger siya ani, then we'll be using L1 as our L. Okay? So this would be the reduced live load. Or you can use the program ani, no? Let's say, ang atong reduced live load is equivalent to, you can use the program na lang, no? Using this command. So, if L1 is less than L2, okay, whichever is larger, no? Then, L, no? Is equals to L2. Else, L is equals to L1. Since ang atong L1 is greater than L2, and ang atong L magawas diri would be, ayan, 2.144. Okay, so this would be our reduced live load, no? So, mali nga. Okay. Of course, we need to include also the partition load, no? Movable partition, okay? We cannot really, usually pag offices siya, natay mga cubicle, di ba? Nagbutan kita mga cubicle, but they are not permanent, they are movable. So we have to include movable partition. Usually, ang ginagamit ana niya, according sa code, 1 PPA siya, no? According to the code, pag movable partition, we have to use a value of 1 PPA. So therefore, ang atong live load now would be, okay, so ang atong reduced live load, okay, so the reduced live load natin plus 1 PPA nga, movable partition, then you have to multiply that with the tributary width, okay. You have now the live load in kilonewton per 5. Kilonewton per meter. Okay, so we have now the